Alright, so in this video I'm going to show you how to make this procedural bouncing ball animation in Blender geometry nodes. Now keep in mind this will not be a complete beginner tutorial, but I'll promise you if you have some basic understanding of Blender geometry nodes and Blender itself, that you'll be able to 100% recreate this animation with ease. Now let's dive right into it. To achieve this animation, we are going to instance a custom object within a grid. We are going to create some procedural animation techniques using a wave texture. And I'm going to show you a neat little trick using a switch node to add some optional noise to the animation. And in the end, I'm going to show you a few procedural shading tricks. As always, if you just want to use the project file for yourself, that will be available completely free in the description down below. Now let's get started. Here my pre-modeled little tunnel that we will use to instance on the grid and to house the balls themselves, to make that housing or tunnel or whatever you want to call that shape in whatever shape you want. Keep in mind that in the end you want the inside to be round to perfectly house the ball. Now you'll notice probably that this is a square housing, but we will later use a subdivision surface modifier within geometry nodes which will turn this square inside into a perfect circle. Now let's just hide this object, unhide our main geometry node setup, and let me show you the node tree. Okay, now that we're finally in geometry nodes, let me just tell you, since this isn't a complete beginner tutorial, I'm going to just show you an overview of the entire node tree and show you some of the most important nodes and how they work. If you would rather have a build along style video, please do tell me in the comments. I am trying to improve my tutorials, but for now, this will be how we do it. So let's start with the grid logic. So everything you're seeing right here, except for the stand and the platform, we're going to mute these two right now so we can focus on the main animation. Everything you're seeing right here is being instanced on this grid right here. So to go into the grid logic, obviously we need an instance on points node on this grid, and the instances on this point will be our custom tunnel object we made right here. To get this custom object in here, we are going to use an object info node referencing our custom object right here. I personally am going to feed this into a subdivision surface modifier, as I told you before, to make my square inside round. You don't have to do this if your inside is already round. Finally, what I like to do is use a value node as a constant input for my scale, so I can just scale my custom object so they just barely start touching. Also, obviously, we need a set material node to set a separate material for our grid right here. After this, we are going to take a look at our ball logic. Let's just call it that. We also are using the same technique we used in the grid logic, plugging our initial grid into an instance on points node, which in this case has an icosphere right here as its instance. I am also once again going to use a value node as a constant input, this time for the radius of our balls. And I'm also going to set a set shade smooth node right before I'm going to instance my balls. I'm just doing this so I don't have to use as many subdivisions on my icosphere right here. Lastly, once again, I'm going to use a set material node so I can have a separate material for my balls right here. As you can see, if I mute this set material node, only the material of the balls will disappear and reappear back on. Great, now let's get into the meat of this whole tutorial. We are having two different kinds of animation. We do have our bounce logic right here, and we do have some optional wiggle noise. Let's start with the bounce logic. The bouncing animation is being set by this set position node. So we are going to use the output of the last node of our balls logic as the geometry inputs of this set position node. And then we are going to add the following nodes. We need a combine XYZ, we need an RGB curves, we optionally need a map range node, and we need a wave texture. The reason why we need those nodes in this configuration is we need the combine XYZ to only manipulate the balls on the Z-axis. We don't want any lateral distortion of our animation, meaning the balls will only bounce up and down. We need the RGB curves node right here set in this little small S-curve configuration so that we can manipulate the timing of our animation. Meaning, if we play this animation like this and we disable the RGB curves node right here, we mute it, we get a little bit of a more non-linear animation to the balls, which looks a little bit more natural and pleasing to the eye. Let's unmute the RGB curves node, just so you can see the difference. We do need the wave texture node set in this particular configuration, rings, Z-axis, and sine, to get the shape of this animation. We want the animation to look like a water droplet falling into water, like a wave texture after all. Let's play the animation once more so you can see this. Let's reset our animation and look at these values right here. These are the values that I used. You can use any values down here that you like, just play around with them to get the animation that you want. The animation itself is being animated through the offset value of this wave texture node. Now, if you want to loop the animation, the only way that I found to do this is to just closely look at the position that you're having at the beginning of your animation and try to set the offset value at the end of your animation to sort of match the position. If you, on the other hand, do not care about a looping animation, just set the offset value animation to something that you like. Great. Now, lastly, the map range node in between the wave texture and the RGB curves node is completely optional. You don't need it. To prove this point, let's play the animation with the map range node and mute it. The animation looks the exact same. If you do add the map range node, it will give you the ability to change the height of the bouncing ball animation. To show you this, let's play the animation once more. Go to the from max value right here and change it from 1 to 2. And you can see now the balls will not bounce as high. Let's pause the animation, go back to 1 and replay it again. Now, to explain the optional wiggle noise logic right here. For this part of the node tree right here, we are going to use the following nodes. We want a random value node, a noise texture node, and a switch node. This logic right here will be plugged in into the rotation input of the instance on points node inside the balls logic. Now let me show you what this little setup right here actually does. To visualize this a little bit better, let's turn down the subdivisions of our icosphere and also mute our bounce logic so our balls stay within our tunnels. Great. Now if I zoom in here again and play the animation, you can see nothing happens to the balls themselves. Great. Pause the animation, set the switch on the switch node right here. Play the animation once more, and you can see our balls randomly rotating a little bit. Now the reason for doing this is firstly just to add a little bit of randomness to the balls themselves, which looks a little bit more natural, but also the effect that I was originally going for was a ping pong ball being blown up by a hairdryer. Now, if you do watch this particular effect, you will see the ping pong ball in the airstream of the hairdryer always rotating a little bit along its own axis. I realized though that in the final animation this effect was almost imperceptible, so I decided to add it as an optional switch logic right here. Now how this works is, first and foremost, the rotation is being driven by the W value of a noise texture. The noise texture has to be set to 4D and normalize has to be unchecked. Then you can play with the scale, detail, roughness, distortion, whatever. You can play with these values to get an effect that you personally like, as always. The vector of the noise texture needs to be driven by a random value node in which you can set the seeds to get some more randomness or proceduralism, more control over the whole setup. Now the meat of this whole setup is the switch node right here. This switch node needs to be set to float, and the factor of the noise texture needs to be set into the true input of the switch node. That way you can turn this whole logic branch right here just off and on however you like it. If you want it inside your animation, turn it on. If you don't, turn it off. Also, as a little additional tip, I animated the vector value in the noise texture node right here via a driver. You can do this just by driving #frame divided by whatever number you need for the animation to look good, and the animation will drive itself via the driver, of course. If you don't want to use a driver, you can just animate this W value via a completely conventional method of your choice. Okay, let's set the subdivisions back up to 3. Let's unmute our bounce logic. Looks good. And let's finish our geometry nodes setup by adding our platform logic and our stand logic. Let's start with our stand logic right here. Let's unmute it right here. Looks great. The stand logic is being driven by a cylinder node, a subdivision surface node, a transform geometry node, and lastly a set material node to set a separate material for our stand. The cylinder right here has the fill type n-gon, vertices 32, segments 3, fill segments 3, and the radius set to 0.5 meters. This is being fed into a subdivision surface node, level 1, which is being fed into a transform geometry node. This transform geometry node is just so I can set the position easily of my stand, just like that. And lastly, of course, our set material to get a different material for our stand. Great. Now, lastly, our platform is being made in a very similar way. Let's unmute these nodes. Our platform also is a cylinder into a subdivision surface, into a transform geometry to obviously set the position to be centered, into a set material node to get a different material node also for our platform. These are the values chosen for our platform. Now the thing I did in the end was I have 2 separate joint geometry nodes right here, one before a transform geometry and one after a transform geometry. This is being done so I can animate only our platform, our grid, and our balls at the same time, going in a circle for the looping animation. Meaning I join every geometry except the stand right before this transform geometry, so I can transform everything except the stand. Now, after this transform geometry node, I'm going to use another join geometry, which adds the stand. Then lastly, I'm going to use a set shade smooth node for all the geometry, so it looks nice and smooth. And that would be our geometry node setup. Great, now let's just play the animation one more time. All looks good. The stand isn't turning, only the platform, the grid, and our balls are turning. Now let's finish all of this off by selecting our geometry nodes object, going into the shading tab and showing you a little bit about shading the different objects right here. Now let's start with the shading of our balls. As you can see, I can randomly select different colors for different balls. The way I'm going to do this is by having 2 different principled BSDF nodes that are being mixed into a mix shader node. I do have an object info node that has its random output going into the factor input of a color ramp, and the color ramp's color output is being fed into the factor input of our mix shader node right here. The color ramp's job, by the way, set to constant, is to manipulate this factor of the mix shader node so that we can select different amounts of black and white balls. The object infos node is to have the random output, which will select random objects that we have instanced in our geometry nodes set up. This way, we can mix two principled BSDF shaders such that each of them has a completely different material. In this case, I have a white rough material and a black glossy material, and they are applied to completely different objects in the end. Great, now let's step over to our platform shading, right here. Our platform shading consists of a single principled BSDF, a color ramp set to linear, a Voronoi texture, a mapping node, and texture coordinates. This last part is actually very important for this setup. We are going to set the Voronoi texture to 4D, distance to edge, and normalize. These values down here can be adjusted to your liking. The color ramp in this case just adds some more contrast to the entire setup. Now the reason we are using a mapping node and a texture coordinate node in this case is, if I can show you, let's mute these right here and play the animation. It looks like the platform doesn't rotate. I'm not entirely sure why that is. I just do know that if I add the setup, unmute it right here, and animate the rotation, specifically the C rotation of this texture setup at the same interval as I animate and rotate the geometry itself within our geometry node setup, it looks like it sticks. Once again, I don't entirely do know why this problem exists. I just do know this right here is the solution. Maybe one of the viewers has an idea why this problem exists. I'd be happy to hear. Write it down into the comments. All right, now for our stand texture, I do have a setup once again of a Voronoi texture, this time set to 3D, distance to edge, with these values right here fed into a bump node and the normal input of our principled BSDF. And then I just adjusted the distance of this bump node so the normal map doesn't look so harsh. Now lastly, we do have our grid material, which in its essence is actually just a complete white color with a little bit of subsurface scattering. The subsurface scattering values I do have right here. I used a weight of slightly over 0.15. This is my radius, my scale, and that's how I rendered the final animation. Now, lastly, I did add a separate backdrop object, as you can see right here, which basically consists of just more of those instance tunnel objects. And I also added a little light setup that you can see right here, but I'm sure you can figure out your own lighting and background setup which fits your needs. All right, this has been an overview of this procedural bouncing ball animations geometry node setup, as well as some shading tricks and some neat little geometry node tricks like this switch node right here. Once again, the full file is available for download in the description down below, completely free of charge. Also, I would very much appreciate feedback to the tutorial style or to the tutorial in general down in the comments below. I am very much trying to improve the tutorials and keep many more coming your way. All right, see you in the next video.